How to find the longest common subsequence using dynamic programming. Problem statement. The input is two strings, the output is the length of the longest common subsequence of the two strings. The common letters do not have to be consecutive, but do need to be in the same order. Example 1. Strings AAB and AZB have LCS of 2, which is AB. Strings A, B, C, and C, B, A all have 1 because it's either A, B, or C. Why is dynamic programming? So, you see, this is a recursion tree. So, B and C are not the same, so you split up in two cases. Where it's B and B, which are the same, so what you do, and then there's A and C, which are not the same. So since they are the same, you cut them both out. So now you have ABA and ABA plus 1. With this, you have ABA and AB, and then AB, and then ABC. So, this one, since the letters are not the same at the end, ABA and ABA and AB and ABAB, these two are the same. Because recursive can compute repeated states, while dynamic programming computes solutions from the bottom up, so they don't repeat anything. So, M and N are the height and width of the matrix. The matrix starts off with all zeros. So, the strings we're using is AAB and AZB. So this will be the dynamic programming table. Since empty string and empty string, anything with empty string is 0. Empty string and empty string is 0. Same with this. A and empty string is 0. Same with that. Same with that. And this. So, since now we're at A and A, and since A and A are the same, then as shown in the code right here, what you do is you look at this value and then you add 1 to it. So, now you're trying to find the longest common subsequence of empty string and empty string, which is already computed as 0. So 0 plus 1 is 1. And now we have AA and A. Since the A and the A at the end are the same, you go to this line again. So you look at A and empty string, which is 0. So you do 0 plus 1, which is 1. Now you have A and AAB. Since A and B are not the same, you go to this line, which you're trying to find the max of this value, which we've already computed AA and A has a max of 1, and this value, which we've already computed AAB and empty string has a max of 0. So a max of 0 and 1 is 1. Empty string with anything will be 0. So then now you look at AZ and A. So you have to go to this line again, since A and Z are not the same. So you look at this one, this line, where you have AZ and empty string. So you're trying to, which we've already computed, is 0. And now you have AA, which we've already computed, is 1. So 0 plus 1 is 1. No, the max is 0 and 1 is 1. Now you have AZ and AA, which Z and A are not the same, so you have to go to this line again. So now you're trying to find the max of AZ and A, and A and AA. So AZ and A we've already computed has a maximum has 1, and AA and A we've already computed is 1. The max of 1 and 1 is 1. Now we have AZ and AAB. So we have to, since the Z and the B are not the same, you have to look at its so then you have to look at AZ and AA, which has a longest common subsequence of 1. And then you have to look at A and AAB, which is longest common subsequence of 1. The max of 1 and 1 is 1. Now you have another empty string with AZB, and an empty string with anything would be 0. So now you have A, Z, B, and A, where A and B are not the same. So you have to look at this, which is empty string, and B, which is 0. And you have to look at this, which is A, Z, and A, which would have a longest common subsequence of 1. So the max of that is 1. Now we have A, Z, B, and AA. The longest common subsequence of A, Z, B, and A is 1, and the longest common subsequence to A, Z, and AA is also 1, and the max of 1 and 1 is 1. Now you have A, Z, B, and AAB. Since the last letters B and B are the same, you remove them. Now we're looking at AZ and AA. So since so now you look and you have the max of AZ and AA is already computed as 1. So you get that value 1 plus 1, which would make 2. So the whole function will return 2 because the longest common subsequence of these two strings AZB and AAB would be 2. Thank you for watching.